Hello, this is Mr. Kinyanola, and I'm going to teach you about square roots. And as I'm teaching you this, I want you to keep in mind one thought. This right here. As it focuses, yes, it is a pair. So as we're going over square roots, think about that nice looking green, luscious, juicy pear. All right, let's go. Write these down and quickly tell me what's the square root of each of these, and then unpause it. All right, let's go over them. Square root of 25 is 5. Square root of 49 is 7. Square root of 81 is 9. And square root of 144, hopefully you got this without using your calculator, is 12. And I'm guessing you thought in your brains, well, if you remember earlier, I told you to think of one word, one fruit, pear. And so as you were thinking about this, you were thinking, what number, if I had a pair of that number, would give me 25? So and you thought, okay, 5 times 5. Okay, not the fruit, but pear as the number 2. What pair gives us 25? Well, 5 and 5. 5 times 5 is 25. 7 and 7. 7 squared is 49. 9 times 9 is 81. And 12 squared is 144. Pair. Pair of 12s gives us 144. A pair of 9s gives us 81. A pair of 7s gives us 49. And a pair of 5s gives us 25. Yes. Hopefully that was simple enough for you. Hopefully that was easy enough for you. But if it wasn't, it's fine. That just means you need to review your square roots. But let's move on. Let's go over this one. What is the square root of 12? Now, you better not say 6, because a lot of noobs say the square root of 12 is just half of 12. No, that's incorrect, because 6 times 6 would be 36, not 12. But remember what I told you to remember. Pear. That green, luscious fruit. Pear. Okay, so let's look for some pears. Not really the fruit, but 2 of a kind. Let's find 2 of a kind. What are we going to do here is let's take this pear-colored pen, and we're going to factor out 12 to see if we could uncover some pears. So, factor. What are 2 numbers that multiply to 12? We have some options. Let's do 3 and 4. You could have done 6 and 2, but let's do 3 and 4. And let's keep on factoring until we get prime numbers. 3 is a prime number. We can't get any other factors than 1 in itself. And let's look at 4. It would be 2 and 2. And we can't factor 2 anymore, so we have 2, 2, and 3 in our factor tree. We're going to ignore this 4 because it's a branch. We're only looking at the leaves of this factor tree, the bottommost numbers. And what did we say? What are we going to look for? Pairs. Do we have any 2 of a kind here? Yeah, we do have 2 of a kind, the 2s. So we're going to circle the pair, not the single, the pair of 2s. So here's 1 pair of 2s. Are there any other pairs of numbers? No, this is a single of 3. There aren't any other pairs. There isn't another 3 to make this a pair. So we just have that pair of 2s. So the square root of 12 would be, we have 1 pair of 2s, so we're just going to write 1, 2, because we have 1 pair. This represents that 1 pair. And then the leftover, that's not circled, that's just a single, is that 3. So we're going to write radical. And the leftover still stays in the radical, 3. And that's it. There's our square root of 12. Okay, so we factored out 12 to be 3 and 4. We factored 4 to be 2 and 2. And we looked for pairs, and we circled that pair of 2s. And then we wrote the 1 pair of 2s. This represents this 1 pair. And the leftover that wasn't circled, that wasn't part of a pair, was that 3. And we put it in radical, the radical. So it'd be 2 radical 3. There's our final answer. Press pause and just think about what we did, okay, so that you can explain this to yourself or to your friend or to your little brother, little sister that looks up to you. And when they ask you, how do I find the square root of something, you can explain to them. Okay, now let's see. How do we check this? In the previous problems, we checked 5 by we checked that 5 was the square root of 25 by squaring it, right? 5 squared, or 5 times 5 is 25. 7 squared would be 49. 9 squared would be 81. 12 squared would be 144. That's how we checked it. We multiplied it by itself. So let's check this. I'm going to put a little check mark here, and just to show that I'm checking it, because it's a check mark. So I'm going to multiply this 2 radical 3 by itself. 2 radical 3, or 2 radical 3 squared. So I'm going to multiply it by itself. How do I multiply this? Well, I'm going to multiply the numbers on the outside of the radical with each other, and I'm going to multiply the numbers inside of the radical with each other. So 2 times 2 would be 4. Radical 3 times radical 3, or square root of 3, whichever word you want to use. So 3 times 3, radical 3 times radical 3 would be radical 9. And then you guys know this. What's the square root of 9? Would be 3. Bring down that 4. And 4 times 3 is 12. So, look at that. We know this is correct because if we squared it, or we multiplied it by itself, it would end up being 12, which was the original problem. All right. So let me give you some more examples so that, hey, the more repetition, the more practice we get, hopefully the easier it gets. So how about you guys write these down, press pause, and factor it out and find some pairs. And then we'll go over it together after you press unpause. All right, unpause. So I'm going to find my pairs. I'm going to factor 72 out. Two numbers that multiply to 72 are 9 and 8. These both are not prime numbers. I could factor them out some more. So two numbers that multiply to 9 are 3 and 3. 8 I could factor out. So some people would stop right there and say, okay, I found my pair. However, there might be more pairs hidden. So find that treasure of pairs. Two numbers that multiply to 8 are 4 and 2. And I could factor out 4 some more to 2 and 2. So look at that. We got a couple pairs there. A couple. So I'm going to circle my pairs. Okay, not the singles. Some people are going to circle 3 and the other. No, circle the pair of 3s and circle the pair of 2s. Remember, the pairs go on the outside of the radical. So our final answer would be, well, 3 times 2, and then what's left over that we didn't circle, that isn't a branch but is a leaf, is this leftover 2 right here. Okay, so I'm going to write 2 right there, and then we can still simplify this, make this look a little nicer. 3 times 2 is 6, and then radical 2. So this would be our final answer. Okay, 6 radical 2 is a square root of 72. If you don't believe me, then multiply this by itself. Guarantee you get 72. All right, let's try 98. Two numbers that multiply to 98 are 2. Okay, I know it's 2 and some other number because this is an even number. So I'm just going to start off with 2. And what are two numbers that multiply to 98? Yeah, 49. If you didn't know that, use your calculator. Cut 98 in half, it's 49. And two numbers that multiply to 49 are 7 and 7. Can we factor out 7 some more? No. So that's it with the factoring. And let's now look for our pairs. We have a pair of 7s, and that's it. So our final answer would be the pairs go on the outside. We have one pair of 7s, and the leftover is 2. Okay, so the tricky part is some people might get a little confused. We have one pair of 7s that goes on the outside, and we have a single. All the singles go inside of the square root. Okay, the pairs, the number of pairs, we have one pair of 7s that goes on the outside. Okay, All right, here's this 128. This one, we have a couple options on how to do. Okay, I'm going to show you the long way, and I'm going to show you a shorter way. So let's start off with this 128. Two numbers that multiply to 128. If you're not great at mental math, just look at it. It's an even number. So all even numbers are divisible by 2. And what's half of 128? 64. Okay, and then here's the long way again, and I'll show you the short way. And two numbers that multiply 64 are 2. Okay, it's still an even number, and 32. 32, two numbers, 2 and 16. Then 16 are 2 and 8. 8 are 2 and 4, and 4 are 2 and 2. Whoa, that's a lot of 2's. So let's circle all of our pairs. We have one pair of 2's. We have another pair of 2's. And we have another pair of 2's. Now, here's what some people are going to do. They're going to say, oh, that's a pair, and that's a pair. Right here, I'm going to write 6 because 2 plus 2 plus 2 is... No. Remember, factoring is multiplication. We're finding numbers that multiply. So what we're going to do is 2 times 2 times 2. And then what's left over that we didn't circle? We got this leftover single 2. Oh, it's okay. You're by yourself, but you're inside of the radical, so you have shelter. All right, and so now let's simplify this. 2 times 2 times 2 is not 6, it's 8. 2 times 2 is 4, times 2 is 8. Radical 2. All right. So that's one way of doing it. Another way that may save our brains some time. Let's write it over here. 128. Okay. We have some options, but let's do the 2 and 64 again. Now, instead of cutting this in half, if we knew that 64 is 8 and 8. Now look at that. We could factor 8 some more. Right, 4 and 2, 4 and 2, and then we'll just get a bunch of 2's again. But look at this. What are we originally looking for? That juicy, luscious green fruit, aka 2 of a kind, a pair. So we already have a pair, this pair of 8's. And I'll write the answer over here. So equals, so we're going to write our one pair of 8. And what's left over? Radical 2. And if you notice, this is the same answer as all of this work right here. Same answer. Less work. But it's okay. So, let's focus. Okay. All right, let's look at this one. Okay, but once you find that pair, going back to this, once you find that pair, okay, you can stop. Put the pairs outside. Here in the first one, we found one pair here, but we didn't know if there were any hidden pairs in this 8, so we just kept going. All right. All right, now, square root of 189. This one's a little tricky if you're not great at mental math, so use your calculator. Is this divisible by 2? No, it's not an even number. Is this divisible by 3 is the question. I believe so. So I'm going to write the 3. How many times does 3 go into 18? 6. How many times does 3 go into 9? 3. So 3 times 63 is 189. And let's find two numbers that multiply to 63. What about 9 and 7? And then how about this 9? Two numbers that multiply to 9 are 3 and 3. So now let's look at all of the leaves in this factor tree. 3, 3, 3, and 7. Are there any pairs there? Yeah, this pair of 3's. Are there any other pairs? No. So we have one pair of 3's, and we have a couple singles here. What's a leaf there that isn't a branch? Well, we have this 1, 3 over here because this one didn't want to join, or these two rejected this one because they said, oh nope, only 2 of us are allowed in a pair. So you're left inside of the radical. And what else is there? That's 7. So we're going to put times 7. Remember, with all factors, we're always multiplying. And now let's simplify this. Let's make this look a little nicer. 3 radical. 3 times 7 is 21. And this is our final answer. All right, and then the last one, 35. What are two numbers that multiply 35? 5 and 7. Can we factor 5 some more? Other than 1 in itself? No. How about 7? No. Both of these are prime numbers. Okay. So, are there any pairs in this factor tree? Anything to circle? No. So these are all singles. All the singles stay inside of the radical, which is just 5 and 7, which is just 35. So, square root of 35 is just square root of 35 because there aren't any pairs in there. Alright, so that's how you simplify a radical, or you simplify a square root without using your calculator, without getting a bunch of decimals that you wonder how did you even get those decimals. So again, think of one luscious, green, juicy fruit. Pears, and then look for them. And put those pairs on the outside and leave all the singles on the inside of the radical. There you go. There's square roots. Have a great day.